Okay, we continue with 7.4. So in the first video, you must have seen that we solved some trig equations. So they were mostly the basic trig equations, and then slightly complicated, but now here are even more complicated. So the first example says sine square x is equal to 4 minus 2 cosine square x. So if you note here, cosine square x and sine square x, they are two different things. So it's not really that easy to solve it in this form. So we have, fortunately, trig identities which we can use and change the equation into a form which we can easily solve. So if you remember, we have the Pythagorean theorem or Pythagorean identity, that cosine square x plus sine square x is equal to 1, and from there we can get cosine square x is equal to 1 minus sine square x. Here on the right I am looking at, and then also we have that we can write sine square x is equal to 1 minus cosine square x. Now note here, so these identities, Pythagorean identities, these are with the square terms. You cannot have anything like cosine of x equals to 1 minus sine x, or sine of x is equal to 1 minus cosine x. These are wrong. Okay, only with squares these are true. So now which one will you use? Will you use this one, or will you use that one? That depends upon you. Now I chose the one where I replace the cosine square x by 1 minus sine square x, and I did my algebra, distributed the two, combined the like terms. So I have now 2 sine square x on the right side plus 2, and then on the left side I have just only 1 sine square x term. So I want to combine these, bring them on the same side, so subtract negative 2 sine square x from both sides. It cancels from here. We are left with negative sine square x is equal to 2, or sine square x is equal to negative 2. Now there will be no solution here because negative 2 is less than 1, negative 1, right? So the values must be between negative 1 and 1. That's why anything out of this we cannot have a solution. Also note here, this is a squared, sine squared, and because we are talking about real values, real numbers, so it cannot have a negative sign, or you cannot take the square root of the negative sign. So we say no solution here. Looking at the next equation, 2 sine square x plus 3 sine x minus 2 is equal to 0. So if you note, this is a quadratic form. If you recall, if you might call it something like this, x to the 4 or 2x to the 4 plus 3x minus 2 equal to 0. So same thing as you see here. So these are quadratic form, but we will not use x here because x is being used in the equation. So I can say let u equal to sine of x, then u square will be sine square x. So I can transform my equation into u over here, and then I factor. Now you should know how to factor this. If not, then I think you can use a quadratic formula. Okay, so we get two values. The one value is 1/2 and the other value is negative 2. You can see from here, one of the values will be 1/2 and the other will be negative 2. Now again, u is equal to negative 2 means sine of x is equal to negative 2. But then again, like in the previous example, you can say, or sine of x is equal to negative 2 is not answer because negative 2 is less than negative 1. It is outside that interval. But the other value of u is equal to 1/2 will become sine of x is equal to 1/2, and we know that this happens when the sine angle is here, angle is here, or angle is here. So which angle? Pi over 6 here and 5 pi over 6 over here. So that's how we do this question. Looking at the next example, same thing, but now notice here, so different from the previous two examples. So in the first example we saw today, we had sine square term here and the cosine square term on here on one side we had a sine square term, on the other side now, and then in the second equation we had a sine square and then a sine squared x and then sine x, but now we have sine squared x and cosine x. So this is, you cannot solve it in this manner, so you have to use the Pythagorean identity. Now Pythagorean identity cannot be used on the cosine x because it's not a square term. So what we do, we have to use it on sine squared x. So what is the identity we will use? We will change the sine squared x into 1 minus cosine squared x, and then do our algebra, distribute, combine like terms, then do the substitution. Now when we have it cosine square term, one term has cosine squared and one term has cosine x, so then it means we can easily think of it as a quadratic form, and then we can do the substitution, find out the factors, set them equal to 0. So one of the factor gives me that cosine of x is 3/2 and the other gives me cosine of x is equal to 1/2. So x is equal to, cosine of x is equal to 3/2 will not be a solution, and cosine equal to 1/2 will be a solution with x is equal to pi over 3 and 2 pi over 3, because remember x is positive, is over here. Okay, so wait a minute, no, this is not correct. X is equal to pi over 3 and the other one will be in the fourth quadrant. That will be 5 pi over 3. So one angle is in the first quadrant and the other one will be in the fourth quadrant, because on this side cosine is positive. Okay, looking at the next one. Now this one can be done actually in two different ways, but notice a common mistake which someone can do, that they say, oh, tangent x is common, so I divide by tangent x. Then if you are doing it, you are losing, you might lose some part of the solution. So what you should do is bring everything to one side and factor. So but what I did here, I first used the identity, Pythagorean identity, and changed this sine square to 1 minus cosine square. So we have only sine square term, but I could have done it like this, that 3 tangent x and bring this on the, so yes, cosine square x minus tangent x into sine x, sine squared x. So then I can factor out the tangent x. Inside I am left with 3 cosine square x minus sine square x equal to 0. Then I have tangent x is equal to 0, or this thing is 0. Now this thing, so I have to now think about, okay, how do I do that? Now in this case we will do that we can separate, we can bring them, one of them on the other side. So can I write like sine square x is equal to 3 cosine square x, and now I will divide by cosine square x both sides. So this is something you have to remember in this type of problem. So this will give me tangent square x is equal to 3. So the tangent x will be equal to plus minus square root of 3, and you will see then, if you remember, that tangent of x is square root of 3 for what angle, and then the same thing for the tangent of x is equal to negative square root of 3. But I don't know, if you that feels easy, you may do it like this, but I did it like this one. In the end, what are the factors are, so tangent x got factored, other factor is 4 cosine square x minus 1, and then when you set them equal to 0, So one is giving you tangent of x is 0 and the other is giving you 4 cosine square x is equal to 1, or cosine square x is equal to 1 over 4, and when we take the square root we get plus minus 1/2 on the right hand side. So the tangent of x is equal to 0. When will the tangent be 0? When the sine is 0. Where is sine 0? Over here at 0 and at pi. So you get 0 pi. And when now from here you got two equations. So for one equation, cosine of x is equal to 1/2, we get this as our solution. Because remember cosine is, so we saw this already, we have had it in the previous example. Cosine of x is equal to 1/2 will give you pi over 3 and 5 pi over 3. But cosine of, so it is one angle is over here and the other is over here. Now for the other equation, cosine of x is equal to negative 1/2, the one angle will be here and the other will be here. So we get 2 pi over 3 and 4 pi over 3. So now I would put all the solutions together here. Next equation, okay, it looks kind of strange or daunting, but it's not very complicated. If you notice on this side, we can factor, if we factor out the cosine, inside we get 2 cosine theta minus 3, and on the right hand side we can factor the sine term because it is present in both. So again we get 2 cosine theta minus 3. Now we do not divide by that because that will by doing that you might lose a solution. So for example, if we had divided by tangent x up there, we would have lost these two values. Okay, so what I do, I bring everything on one side and set it equal to 0. Now in this case, if you look, you can factor out the 2 cosine theta minus 3, and then the other factor will be cosine of theta minus sine of theta. So set each of them equal to 0. When we set the first one equal to 0, we end up getting cosine of theta is 3 over 2, which means there is no solution. Why? Because 3 over 2 is bigger than 1. And then for the other equation, cosine of theta minus sine of theta equal to 0, how do we solve it? So always remember, this is kind of something to remember whenever you have equations like or note here, if you have an equation like this, cosine of square theta minus sine square theta equal to 0, can you see it can be factored into these two equations? So this will become cosine of theta minus sine of theta times cosine of theta plus sine of theta, which means these two equations, so you set them equal to 0. So in these both cases, what you do, you will move one of the terms on the other side, keep one over here. So in the first one, if I move the cosine, I get that. So the next step will be divide by cosine. So it becomes tangent of theta equal negative 1. And that will happen at negative pi over 4, or if we are going to be in the second quadrant, it will be 3 pi over 4. So theta will be 3 pi over 4, and then in the fourth quadrant it will be 5 pi over 4. And if you have the other equation, cosine of theta minus sine of theta, so you move one on the other side, we get what we have here. So tangent of theta equal to 1. So this is going to happen in the first and the third quadrant. So in the third quadrant, okay, I think this was 7 pi over 4. Fourth quadrant, the angle will be 7 pi over 4. Here it will be in the first quadrant and the third quadrant. So we get theta equal to pi over 4 and 5 pi over 4. Okay, so now the last question here. So we have now 2 secant square theta plus tangent square theta is equal to 3. So what will we do here now? We will can use our Pythagorean identity that 1 plus tangent square x, or in this case tangent square theta, will be equal to secant square theta. So that's what I used here. So now the equation is in tangent. So just the same thing that I did before. Combine the like terms. If it can be factor. If it's simpler than that, which in this case it is, combine the like terms, we get 3 tangent square theta and then is equal to 1. So 1 tangent square theta is equal to 1 over 3. So tangent of theta will be plus minus 1 over square root of 3. We rationalize, we write it like plus minus square root of 3 over 3. And now individually those two equations, and then we can give our theta. Because again, remember, it will be positive here and positive here. So in the third quadrant, it will be 4 pi over 3. First quadrant, pi over 3. In this case, it will be in the second quadrant and in the fourth quadrant. In the second, it will be 2 pi over 3. In the fourth, it will be 5 pi over 3. So our final answer in this last example will be theta equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So this is how we find the solutions of the equations.